All right. First topic we're going to talk about today is doubling the area of something. And as a lead into that, the first thing I want to mention is how many square feet are in this rectangle. And at first glance, you look at it and you go, well, that's just the area of this rectangle. And I know the area of a rectangle is length times width, so I'll just multiply 6 yards times 2 yards. So the area of this would be 12 square yards. And that's entirely correct. Problem with that answer is that the question said, how many square feet are in this rectangle? And there's a little bit of a danger here in, okay, well, if I multiply 6 yards times 2 yards and get 12 square yards, since there's 3 feet in a yard, we multiply that by 3 and get 36 square feet. I said there's a little bit of a danger there. We're going to get rid of this and talk about why. Multiplying by 3 doesn't really work there. Let's go ahead and change the dimensions of this from yards into feet where they're sitting. So instead of 6 yards, we're going to go ahead and call that 18 feet because that's what it would be. Instead of 2 yards, we'll call that 6 feet because that's what it would be. And now if I want the number of square feet that are in this rectangle, at this point, I'm going to go, well, I have 6 feet by 18 feet. So I'll multiply those. The area is going to be the length times the width, 6 times 18. That's 108 square feet. We know for sure this way is correct because this is 18 feet, this is 6 feet. So this answer here is the correct one. The problem with this approach over here is I want you to notice what we did when we converted yards into feet. When we did it correctly, we had to multiply 2 yards times 3 to get the number of feet, and we had to multiply 6 yards times 3 to get the number of feet. So we've multiplied by 3 twice. When we did this flawed approach over here, we only multiplied by 3 once, and that's why it didn't work. So that's what I want you to keep in mind if you see something like this, where we're going, this is in yards, but it's asking me about feet. Go ahead and change the dimensions right there where they're given to you. Don't try to calculate it in yards and then convert to feet. It's possible to do it correctly this way. You just have to multiply by 3 twice, not once. That's an easy mistake to make, though. So I think it's better to go ahead and convert those right out of the gate. And now you know you're multiplying 6 feet times 18 feet and ending up with 108 square feet. Let me know if you have any questions on that before we look at another problem related to doubling the area of some figure. All right. You have a square that's 4 centimeters by 4 centimeters, and you want to double the area. What will the side lengths of the new square be? I like drawing a picture of these. So if I have a square that's 4 centimeters by 4 centimeters, there's my square. The obvious thing to try here, again, not the correct thing, but the obvious thing is to say, well, if I double the area, then I'm just going to make this 8 centimeters by 8 centimeters, and I've doubled it. Well, let's see how this plays out, though, because the area of this light blue square that I have, 4 times 4, that's going to have an area of 16 square centimeters. Over on the right, though, when I do 8 times 8, that's 64 square centimeters. I was supposed to double the area, and that's way more than double, so that's no good. If I double both of the side lengths, it won't work. Okay, so that's no good. So we're not just going to double the side lengths. That's not going to be any good. What if I double one of the side lengths and not the other, and I go, now it's 8 centimeters and 4 centimeters. Well, that would work as far as the area goes. That would give you 32. It's double, but we were supposed to have a new square. And now what we have is a rectangle. So that's no good either. This problem actually turns out to be a little more complicated than it first appears. Usually we read something and think it's harder than it really is. This is one where we read it and we think it's easier than it really is. Well, I'll just double it and make it 8 by 8. I'll make it 8 by 4. That works. Wait, not a square. So here's how we're going to go about doing this. We're going to take things that we know. I know the area of that is 16. So I want my new area to be 32. And I'm going to start working from there. The area is going to be 32, and I need this to be a square, which means the length and the width have to have the same value. So I can call them each x. All right then. So if I wanted the area of this, it would be x times x, or x squared, has to equal 32. Oh, the way we'll find out how big the side length has to be then is we'll take the square root of both sides. We'll square root over here because square root and squaring cancel each other. I'll square root over here, and the square root of 32 is 5.6568. And that keeps going. Let's just, because I said so, we'll round to the nearest hundredth. We'll find the hundredths place. We'll look one space to the right. That's 5 or bigger. And so our side length has to be 5.66. Not as easy as it reads. It reads like, well, if it's 4 by 4, I'll just make it 8 by 8. That didn't work. Instead, let's go ahead and double that area. And then, since I know it has to be a square, I know length and width have to be equal to each other. So I can set up this equation to solve to find out what the new side length would have to be to double the area. Let me know if you have any questions on that before we move away from doubling the area. All right. Arc length. This is a term that might be new for you. And the idea here is if we have a circle, an arc is a piece of a circle. And what I mean by that is like from here, say, to here. That right there, that little piece of a circle, that's called an arc. What we're going to do is we're going to be able to find out the length of an arc, and we're going to use circumference to help us do that. Our process is going to be something along these lines, where let's say we have a circle, and this is one of those questions. There's been a couple of times I would have asked y'all questions already, but I want to just make sure we keep moving quickly. This is another one of those. We know that all the way around the circle is 360 degrees. And if I have an arc somewhere on my circle, so we'll just do one similar to what we did before. If I have an arc right here, then there's going to be some angle that goes with that arc. So what we're going to do is we're going to use a proportion to give a relationship between how big is your angle, because that correlates to the arc length, compared to what is your circumference all the way around the circle that corresponds to 360 degrees. And so that's how we're going to answer questions related to arc length. We're going to compare the whole circumference goes with 360 degrees. This arc length goes with whatever angle I've been given. Let's look at an example of this, and I think it'll become a lot more clear. A circle has a radius of 7 inches. Rounded to the nearest hundredth, how long is the arc that is cut by a 25-degree angle? I'm going to draw a picture of this. You don't necessarily have to, but I find it really helpful. So I have this circle, and it has a radius of 7 inches. Rounded to the nearest hundredth, how long is the arc that's cut by a 25-degree angle? So if I were to put a 25-degree angle on here, you could put it anywhere. It doesn't matter where you put it. I'll just put it from here to there, and there's my 25-degree angle. So what we're being asked about is how long is that piece of the circle right there? We can't use Pythagorean theorem because these aren't line segments. This is a curve up here, this arc. So we can't use a line segment. That arc, we'll just call it, I don't know, let's call it S. And it's weird to use S as a variable, but it is very common to use S as the variable for arc length. So I want to go ahead and make sure you've seen that. I don't like S as a variable because it sure does look like a 5 a lot of times, but it is typical to use S for arc length, so that's what we'll do. And here's how we're going to go about this then. The relationship we're going to set up here is going to be, well, if I have the entire circumference of the circle goes with 360 degrees all the way around, that's going to be proportional to however long my arc length is and that 25-degree angle. Please let me know if that philosophy, if the logic of this doesn't make sense. But essentially what we're saying here is this. We're saying, all right, so circumference is all the way around the circle, and that's 360 degrees. So we'll make a relationship between those. And this arc length that I'm after is only 25 degrees of the way around the circle, so we'll make a relationship between those. And once we solve that proportion, we'll know how big our arc length is. Of course, we'd have a little side job to do first, because we can't answer this question until we know what the circumference is. Well, see, I'm told the radius is 7 inches and circumference is 2 pi r. So circumference is 2 times 3.14 times the radius. And let's see, 2 times 3.14 times 7 is 43.96. And so now I know what my circumference is. I can put that in there. So I'll have 43.96 correlates to 360 degrees. How far correlates to 25 degrees? Again, let me know if you have any questions about anything we're working on. I know I'm going pretty quickly. I'm not really pausing to give you a chance to comment. So it's a little different than a normal day. Maybe you're like, great, finally, go fast. If so, I wish you would have told me a month or two ago, but that's all right. Let's finish this up. We'll cross multiply. 360 times S is whatever 43.96 times 25 is. 1099. And then to get S by itself, we'll divide by 360 on the left. We'll divide by 360 on the right. These cancel, leaving S, and dividing by 360, we get 3.05277. Here we were told to round to the nearest hundredth, so that's what we'll do. Find the hundredths place, look one space to the right, that's 4 lower, so we'll round this down, and here our arc length is 3.05. Since it was inches, it would be inches, but your answer would just be the 3.05. And so what we're saying here is if it's 43.96 inches all the way around the circle, then this little piece right here is 3.05 inches long. Let me know if you have questions on that before I have you try one. Okay, here goes. A circle has a radius of 9 inches. Rounded to the nearest tenth, how long is the arc that is cut by a 35-degree angle? I'll make a poll for this so you can try it. Finding arc length, definitely something that I'll expect you to be able to do. Relatively straightforward process once we understand that we need to find the circumference and then set up a proportion. We'll go another 20 seconds on this, and then we'll talk about it together. All right, let's see how we did on this one. Unanimous. Fantastic. Okay, very good. So we'll go through this relatively quickly just to sort of make sure we're all on the same page, but it sounds like we're in good shape here. So when we read this and we see a circle has a radius of 9, how long is the arc? So as soon as we know we're being asked for arc length, we know what we're looking for is we're going to set up a proportion here. And our proportion is going to be the circumference over 360 degrees is equal to the arc length over whatever angle I've been given, which here is 35 degrees. First thing I'll have to do is find the circumference. And let's see, circumference is going to be 2 times pi times the radius, which I was told is 9. So let's see, that's 2 times 3.14 times 9 is 56.52. And now I can set up my proportion. So 56.52, the circumference all the way around the circle, correlates to 360 degrees in the same way that this arc length correlates to 35 degrees. And we'll cross multiply and have 360 times S is 56.52 times 35, 1978.2. I'm not going to do any rounding until we get to the very end. We're going to keep everything until we get to the very end. Here to get S by itself, we'll go ahead and divide both sides by 360. These cancel, giving us S is 5.495. And I was told in this one to round to the nearest tenth. So we'll go find the tenths place, look one space to the right. That's 5 or bigger, so we'll round up to 5.5. The poll is unanimous, so I feel pretty good about it. Let me know if you have any questions there. Okay, we've talked about doubling areas. We've talked about arc length. Up next, we're going to talk about volume. So far, we've talked about perimeter, which is just one dimension. Walk around the figure, how far did you go? We can think of this in terms of being a fence. And our units are inches, centimeters, feet, yards, miles, something raised to the first power because it's just a straight line distance. The second thing we talked about was area, which was more thinking about like a carpet. How much space does it cover? And because when we're talking about how much space does it cover, we have length and width. Now we have square inches, square centimeters, square feet, square miles, whatever it might be. How much space does it take up? What we're going to do as we move to volume is we're going to add a third dimension. Now, instead of just walking around a fence or putting a carpet on a floor, now what we're going to do is we're going to have not just length and width, but we're also going to have height. Now we're going to be talking about, say, a box. How much stuff can you fit inside the box? What is the volume of that box? And because we have 3 dimensions, length, width, and height, now we're going to be talking about cubic inches or cubic centimeters or cubic feet. If you've ever bought a refrigerator, they like to tell you how many cubic feet you can fit inside that refrigerator. When they say that, they're talking about the volume of that refrigerator. How much stuff can fit inside? If our units are in square feet, say, what that's saying then is how many 3-dimensional 1 square feet could you fit inside this box? That's when we say cubic feet, that's what we're talking about. A cube that's 1 foot by 1 foot by 1 foot, how many of those would go inside the box? Let's take a look at finding the volume of a box. Find the volume of a box with a length of 9, a width of 4, and a height of 2. You don't necessarily have to draw a picture for this, but I'm gonna draw a box, and let's see, it's gonna have a length of 9, a width of 4, and a height of 2. You can see there, my 2 looks like it's longer than my 4. That's okay. I wasn't trying to make a perfect picture here. I just wanted something that would orient me, something that would sort of give me a sense of what it is I'm working on here. And so I want to find the volume of this box. How much stuff would fit inside? The way we're going to develop our formula for that is, first, I want you to think about the area of the box, which would just be the bottom down here, length times width. And then, so you kind of think of it as a piece of paper on the table, and then you just add some height to that by putting more and more pieces of paper on top of the other one. So now you have height that goes with it. And then exactly what you might think. The volume of a box is just length times width, which gives us the area of the base multiplied by however tall it is. Length times width times height. That's going to be our formula for the volume of a box. More formal name for a box that you may see at some point, I probably won't use it, but our book might, is rectangular prism. Prism is 3 dimensions. It's got the shape of a rectangle, but it's a 3-dimensional rectangle, so it's a rectangular prism. I prefer to use the word box, but if you see rectangular prism, that's what it means. So here, if we want the volume of this box, we're just going to say, well, the volume is the length multiplied by the width multiplied by the height. 9 times 4 times 2. Let's see. 9 times 4 times 2 is 72. And this was inches, and we know it's volume, so it would be cubic inches. 72 cubic inches would be the volume of this box. We could fit 72 1-inch cubes inside there. Any questions on any of that? Okay, sticking with the box. Now let's talk surface area. What the surface area is, isn't how much stuff we can fit inside. What the surface area is if I added up how much area every one of the sides is, what would we get? The sum of the area of the faces. And what you see in this picture here is we have a picture of a box, and then over on the right, it's like that box sort of unfolded and laid flat, like we're going to recycle it. So it's been unfolded and laid flat so we can see all the sides. And what we're looking for is the total area of all those sides. Keeping in mind that what we have here is we have length, we have width, and we have height, we're going to develop the formula for surface area. So let's see here. If I look at the top of this box, I look at the very top of this box, what I see there is my dimensions. Let's see, that's length times width will give me the area of the top. So this is for surface area, and length times width gives me the area of the top. No, don't write cubic inches on the exam. There's too many ways to do that. There'd be so many different ways, because you could put CU period space IN period. You could put inches cubed the way you typed it, Nadine. You could do that without spaces. You could do the way you've done it with spaces. There's just so many ways for that to go sideways that you'll just type in the number. Sorry for not seeing that sooner. For surface area, on the top, we have length times width. And then the top and the bottom are the same as each other, so we have 2 of those. So 2 times length times width. That gives us the top and the bottom. Then we also need the surface area of, let's say, the front and the back. If we want the surface area of the front, that's going to be length times height. So the front is going to be length times height, and the front and the back are the same as each other, so we're going to need 2 of those, and we'll add those together. And so far in our formula over here, we have the top and bottom, and we have the front and back. Now we just need the left and right. On the right-hand side, that's width times height. So width times height will give us the right-hand side. Since the left-hand side is exactly the same, we have 2 of those. And so our formula for the surface area of a box is 2 times length times width times 2 times length times height plus 2 times width times height. Let me know if you have any questions on how we built that formula. Outstanding. Okay. I want you to try finding the surface area and volume of a box. So we're using those two formulas we looked at just in the last couple of ideas. Find the surface area and volume of a box with a length of 6, a width of 5, and a height of 3. Just as a reminder, volume was length times width times height, and surface area was 2 times length times width plus 2 times length times height plus 2 times width times height. With that in mind, I'll set up a poll for this so that you can try those. In the poll, surface area is first, volume is second. So surface area followed by volume. Really, this is about being able to use those two formulas. I want you to have a really good understanding of how we got those formulas, where those formulas came from, what each little piece represents. But when you're asked to find the surface area and volume, it's really about using those formulas. Definitely the kind of question you can expect to see, in practice, on a quiz, on an exam. Um, Finding the surface area and volume of a box. If you get an answer that's not one of the ones shown, pick the one closest to yours so that I know that you've had enough time. And if you need more time when I start to say we're about done, you just let me know. Go another 15 seconds, and then we'll talk through it together. All right, let's see how we did on this one. Unanimous again. Outstanding. We're having a really good day. That's terrific. Okay, so as we go to find the volume and the surface area and volume of this box, we're just going to use those formulas. You can draw a picture of the box if you want to, but you don't have to. The first thing we were asked to find was the surface area. So we'll go ahead and do that first. Surface area here is going to be 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Really easy to make a mistake plugging in numbers there. So this is the kind of thing, if you're doing it on a quiz or an exam, I might write it down twice and just to make sure that I didn't goof it up somewhere, because it's really easy to make a mistake with that many things to plug in the right spot. All right, so let's see here. 2 times 6 is 12 times 5. What is that, 60? Yeah, 60 plus 2 times 6 is 12 times 3 is 36. 2 times 5 is 10 times 3 is 30. And then we'll add those together. 60 plus 36 plus 30. Our surface area is 126. It would be square inches because we're talking about surface area. You'd just answer with the 126. Volume is easier than that. Volume is just length times width times height. So 6 times 5 times 3. 30 times 3 is 90. This would be cubic inches because it's volume, but we just respond with the 90. So that's our surface area and volume of a box. Let me know if you have any questions on that. All right, we're going to stick with surface area and volume, but we're going to move on to a different shape. And that shape is a cylinder. And a cylinder, and I'm terrible at drawing top of a cylinder, you just have to live with it, sorry. So there's a cylinder. When you think about a cylinder, I want you to think like a can of soup. That's a perfect visual for a cylinder. And we want the volume of a cylinder that has a radius of 6 centimeters and a height of 15 centimeters. So here I have a radius of 6, I don't like that, and a height of 15. And what we want to do is figure out the volume of that. How much stuff would fit inside? The idea we're going to use here is very similar to what we did with the rectangle, where we said, okay, how much stuff fits on the bottom? Well, that's a circle. So if I found the area of that circle, that would let me know how much stuff fits on the bottom. And the area of a circle is pi r squared. And then I find this funny, you may or may not. Imagine a piece of bologna sitting on the table. It's perfectly round. That's the bottom of our cylinder. And then we put another piece and another piece, and we stack it up, stack it up, stack it up till we have a cylinder. Basically, what we've done is, okay, the area of this multiplied by how tall it is. Same thing we do with the rectangle. The area of the base multiplied by how tall it is. That will give us the volume of a cylinder. And I put CYL down there just to differentiate this from the box. You know, volume of a box was length times width times height. Volume of a cylinder is pi r squared times h. Here in this example, if I want to find the volume of this particular cylinder that has a radius of 6 and a height of 15, the volume of that cylinder will be pi times the radius squared times the height. Be careful with order of operations here. Remember, we do exponents before we multiply. So we're going to do that exponent first and have 6 times 6 is 36. And now we just need to multiply those things together. 3.14 times 36 times 15, 1,695.6. These are centimeters. It's volume, so they'd be cubic centimeters, but our answer is just the number right there. Let me know if you have questions on this before I have you try one. Excellent. Okay, here goes. Find the volume of a cylinder with a radius of 2 feet and a height of 7 feet. Round your answer to the nearest tenth. I'll make a poll for this so you can try it. Let's go another 15 seconds on this one, and then we'll talk about it. See how we did here. Unanimous again. All right, we're not having any troubles today. That's great news. If you're having questions, though, please don't hesitate to ask them. If other people are just answering the poll correct over and over and over again, and you're not entirely sure of how they're getting those numbers, please make sure you ask. All right, so we want the volume of a cylinder. So the volume of a cylinder is pi r squared h. And here we are told, let's see, that the radius is 2 and the height is 7. So this is going to be 3.14 times the radius squared times the height. So that's 3.14. 2 squared will be 4 times 7. And then we'll multiply all that together. 3.14 times 4 times 7 is 87.92. We were supposed to round this to the nearest tenth. Make sure you're careful about following those rounding instructions. Round to the nearest tenth, so we'll find the tenths place. Look one space to the right, that's 4 lower. So we'll round this down to 87.9. It's volume and they're feet, so it would be cubic feet, but we just say 87.9. You probably know this one's coming, but up next, surface area of a cylinder. So we're sticking with the cylinder, we're sticking with that soup can shape, and now what we want is the surface area of that cylinder. Keep in mind what the surface area means. It's, okay, I have this piece down here on the bottom, I have this piece up here on the top, and then I have all this metal, if it's a can, right here, that is the sort of the tube part of my cylinder, and I've got to figure out what is the surface area. And that can be a hard thing to sort of think about for a minute. The relatively straightforward part that's generally pretty comfortable is we have a circle on the bottom and we have a circle on the top. And as far as area of a circle goes, I know what that is. That's just pi r squared. And then because I have one on the bottom and I also have one on the top, that means there are 2 of those circles. So 2 pi r squared is going to need to be a part of my formula. Now, how do I deal with that piece in the middle? And the way I want you to think of it is, think of the label on a soup can. If you were just to cut that vertically and then take it off of the can and lay it down flat, when you take that label off of the can and lay it down flat, it makes a rectangle. And so it's the area of that rectangle that we need to add to what we have so far. And the area of that rectangle is going to be, well, let's see. The height is just the height of the cylinder, however much that is. The width is a little bit strange. Like, how far is this distance? Well, imagine we're starting here and we're going all the way around the circle. That was the exact wrong color. Sorry about that. We're going around the circle. And so we're going all the way around the circle. This side length here is going to be the circumference of the circle. So it's going to be circumference of the circle multiplied by the height of the cylinder is how we're going to get the area of that rectangle. So for just that rectangle, let's see, circumference, well, that's 2 pi r, and then multiplied by the height, 2 pi r h. So the 2 circles added together are 2 pi r squared. That rectangle piece that we need to make sure we include, that's 2 pi r h, and we'll add those together to get the surface area of a cylinder. It's a formula that when you look at it is pretty complicated to look at. 2 pi r squared plus 2 pi r h. But when you think about where it came from, it's not so bad. Essentially what we're saying is that's our 2 circles that are on the top and the bottom. This is our rectangle in the middle that is the circumference times the height. Okay, do you have any questions about how we built that formula before I have you try one where you find the surface area of a cylinder? Okay, here goes. Find the surface area of a cylinder with a radius of 8 centimeters and a height of 18 centimeters. I'll set up a poll for this and let you try it. Be careful on this one. Make sure you follow order of operations carefully. The problem doesn't tell us how to round, but you can see in the poll answers that we're rounding to the nearest hundredth. So this one's primarily about using the formula, making sure to do order of operations, and being careful. Let's go another 20 seconds, and then we'll talk about this one. All right, let's see how we did here. Okay, not unanimous. First time today. All right, so let's be careful as we go through this one. So what we're looking for here is the surface area of a cylinder, and we want to make sure we're using the formula correctly and being careful with our numbers. And so surface area of a cylinder is, the formula for that is 2 pi r squared plus 2 pi r h. So let's plug in and see what happens. So we'll have, let's see, 2 times pi times the radius squared plus 2 times pi times the radius times the height. Finally, we get to use the height. And so that's our plug-in. Now we have to get to a place where we, oh, all right, maybe that's good, Summer. If you notice, if you catch it, if you can catch it yourself, there's a ton of value in that. So that's fantastic. Okay, looking at this, order of operations. There's no work for me to do inside parentheses, but I do have an exponent, so we'll do that first. 8 times 8 will be 64. All right, parentheses are done, exponents are done. Now multiply and divide from left to right. I can do all my multiplying in here. Let's see, I have 2 times 3.14 times 64. That's 401.92. And then on the other side, I have 2 times 3.14 times 8 times 18. And that's 904.32. And finally, adding those together is 1306.24. We're talking about surface area, and we're talking about centimeters. So this would be square centimeters. But you just answer with the 1306.24. Let me know if you have any questions on that. A lot of formulas today. So make sure you're using the appropriate formula. Be careful when you plug in, and then make sure you follow order of operations when you evaluate. One last thing I want to say about 9.2 and 9.3 is number 32 in the homework is about Eratosthenes, and it would be easy to let this one sort of float right by. Eratosthenes was an ancient Greek mathematician who measured the circumference of the earth. Eratosthenes measured the circumference of the earth in 240 BC. So the ancient Greeks apparently knew the earth was round because there was a mathematician looking for the circumference of it. Somewhere that got lost in the Middle Ages and people started to think that it was flat, but Eratosthenes in 240 BC was looking for the circumference of the earth. A cool thing about that problem is He knew the Earth was round. Anybody have any questions on 9.2, 9.3 before we get to our review for the final quiz? All right. First, I want to say I understand a certain bit of apprehension about a final quiz because it just sounds so significant. But really what this is main ideas from the course that I'm pretty sure you're probably comfortable with already. And just a little refresher is going to get you to a place where you're really comfortable with these ideas. It's going to be proctored, but that's not a new situation for you. And this is, you know, you don't have to connect to a live proctor. You don't have to make an appointment. So it's sort of lower level of proctoring than we've had for our exams. And like I mentioned before, it's going to be multiple choice. It's 8 questions, multiple choice. You only get 1 attempt. I want to make sure you do your best on it. But let's take a look at some of these. Measures of central tendency. Oh, one thing, that's the other thing I wanted to say about the final quiz. It's kind of nice to talk about these. Some of these things you'll see again when we do our review for exam 3 on Tuesday of next week. Okay, find the mean and median for the following data set. Round the mean to the nearest 100. And remember, the mean is what we get when we add them up and divide by how many there are. So that's 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7 divided by however many we have. 1, 2, 3, 4, 5, 6, 7. So we'll divide by 7. So we'll add those up. 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7 is 34. Divided by 7 is 4.8571. And here we were told to round to the nearest 100th. So we'll find the hundreds place, look one space to the right. Mine's kind of sloppy there, but that's a 7. So we'll round this up to 4.86. I'm going to make that actually look like a 7. So we rounded up because it was 4.8571. That was 5 or bigger, so we rounded up to 4.86 for the mean. We're also asked to find the median here. And if we're after the median, that's going to be the number in the middle. But make sure you write them from lowest to greatest first. So let's see, that's going to be 2. Got a couple of 3s in there. A 4, a 6, a 7, and a 9. 1, 2, 3, 4, 5, 6, 7. Okay. I have 7 data points. That's an odd number. When there's an odd number, there will be one right in the middle to be the median. There's 7 total data points. There's 1 right in the middle, so there are 6 other data points. Half of those, 3 will be lower than the median. Half of them, 3, will be higher than the median. And so if I want to find my median, I'm just going to count over. Let's see, I need 1, 2, 3, 1, 2, 3, and my median is this number right here in the middle. It's that 4. If it turns out that you have an even number of data points in your data set, let's just say, for argument's sake, that this 4 was not a part of our data set, and we only had 6 data points, but we still want to find the median. Then we find the 2 numbers that are closest to the middle, the 3 and the 6, and it is the mean of those that would be the median of our data set. If you have an even number, find the 2 closest to the middle, find the mean of those, and that's the median of your data set. As we go through these, feel free to ask questions if you have them. Weighted averages. One of the ways we looked at weighted averages was in calculating the grade of a particular student. In Lacey's math class, homework's 25% of her grade, quizzes are 30%, and exams are 45%. Rounded to the nearest 100th, what is her overall percentage in the class? So each of these categories is given a certain weight that we're going to factor in. The first thing we need to find, though, is the mean for each. So, like that one. So for homework, we need the mean homework score. And let's see, that's going to be 100 plus 80 plus 0 plus 85 divided by 4. Oops. 100 plus 80 plus 0 plus 85 is 265 over 4. Make sure you divide by 4 if this happens. We don't throw that 0 out. That's one of the grades, so we keep it. So 265 divided by 4 is 66.25. And we're not going to do any rounding until we get to the very end. So 66.25 is going to be the homework mean. We're also going to find the mean for quizzes. And that's going to be 90 plus 72 plus 90 over 3. Oops, that's 252 over 3, which is 84 right on the dot. So 84. And then the exam average, well, we don't really need to calculate it because there was only one exam and Lacey got an 85 on that. So now we're ready to calculate her overall grade using these weights. Homework counts 25% of her grade. So we're going to take that homework mean and the 66.25, and we're going to multiply it by 25%. But we're going to write 25% as a decimal. Then we're going to take a look at the idea that quizzes count for 30%. So we're going to find that quiz mean of 84% and multiply it by 30%, but we'll write it as a decimal. And then finally, the exam average, which there was only one exam, that's 85, multiplied by how much weight do exams get? 45%, so we'll multiply by 0.45. Essentially what we've done here is, this is the mean for that category multiplied by its weight. The mean for the category multiplied by its weight. The mean for the category multiplied by its weight. And now all we need to do is simplify this, and we'll have Lacey's overall percentage. We'll multiply first, following order of operations. 66.25 times 0.25 is 16.5625. Don't do any rounding until we get to the very end. 84 times 0.3 is 25.2. And then finally, 85 times 0.45 is 38.25. We'll add those together. $80.0125. And last, we can finally round. It said rounded to the nearest hundredth. What's her overall percentage? So we'll find the hundredths place, look one space to the right. That's 4 or lower. So we'll round this down to 80.01. Way to go, Lacey. You got the beat. Again, with any of these, let me know if you have questions. Counting permutations, there are 8 students in a class. How many ways can 3 of them be arranged for a photo? I think the hardest part of this question is it a permutation or a combination? And these students are going to be arranged for a photo. That means that order matters. And when order matters, we know we have a permutation. Formula for permutation was n factorial over n minus r factorial. And here we have a total of 8 students. So 8 total students, and 3 are going to be put in this photo. So this is a permutation of 8 things taken 3 at a time. Perfectly fine if you want to use an NPR button on your calculator instead of using the formula. I'll go ahead and do it with the formula just so you can see it. That'll be 8 factorial over 8 minus 3 factorial, or 8 factorial over 5 factorial. And now I'm going to rewrite 8 factorial, because that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I'm going to write 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I wrote 5, 4, 3, 2, 1 as 5 factorial because I have 5 factorial in the denominator, and those 2 will cancel. And so all I'm really left with here is 8 times 7 times 6, which is 336. How many different ways could 3 of these 8 students be arranged for a photo? 336 different ways. Again, if you want to use your NPR button, completely fine. And let me know when you have questions. A basic probability question. Remember, the main thing about probability is successes over outcomes. Keeping that in mind, there are 18 balls in an urn. 8 of them are red, 7 of them are white, and 3 of them are blue. 1 ball selected at random. What's the probability that it's white? So we're just going to pick 1 ball out here. So the probability of getting a white ball, well, successes over outcomes. There's 18 total balls, so that's our outcomes. How many of them are white? It looks like 7. So the probability of getting a white ball is 7 out of 18. Expected value, let's take a look at this spinner here. Expected value was a formula that we had where the expected value was probability of event number 1 multiplied by result number 1 plus probability of result number 2 happening multiplied by result number 2 happening, all the way till we get to the end. When we see an expected value problem, we're going to set this up where we have what are our possible results and what are the probabilities that go with them. And when I look at this spinner here, I can see, well, if I were to have this spinner and I spin it around, 1/4 of the time, it's going to land on plus 12. 1/4 of the time, it's going to land on -5 on -3. And half of the time, it's going to land on -5. The results that could happen, the things that could possibly happen if I played this game is I could win 12, I could lose 3, or I could lose 5. And the probabilities that go with those, well, the probability of winning 12 is the probability that the spinner actually lands there. That's 1/4. Probability that I lose 3 is the probability the spinner lands there. That's 1/4. And the probability that I lose 5 is that 1/2 down there. But instead of 1/2, I'm going to go ahead and write this as 2/4 because with these expected value problems, it's nice when they all have the same denominator. So instead of 1/2, I'm going to go ahead and write that as 2/4. I'm just going to imagine that it's cut into 4 equal pieces, and down there's a -5 over here and a -5 over here. 2 out of the 4 have -5 in them. Now my denominators are all the same. That's going to make it easier for me to simplify later on. Let's find our expected value. Okay. 1/4 of the time, the player is going to win $12. Probability of result number 1 multiplied by result number 1. 1/4 of the time, they'll win 12. We're going to do the same thing with the others. 1/4 of the time, they're going to lose 3. And 2/4 of the time, they're going to lose 5. Now we just need to simplify and we'll have our expected value. You might find it helpful to rewrite those whole numbers as fractions before you multiply. That's totally fine. And now continuing our process of simplifying, we're going to multiply numerators. 1 times 12 is 12. Multiply denominators. 4 times 1 is 4. 1 times -3, make sure you bring the negative along. 4 times 1 is 4. And 2 times -5 is -10. 4 times 1 is 4. The reason that it's nice to have the same denominator all the way throughout is because at this point we're going to need to add these. If they didn't have the same denominator, we would have to find a common denominator to use. Since we set it up where, hey, look at that, they all had the same denominator right here in this probability column, I don't have to fool with that now. They already have a common denominator. So I'll just add these fractions. I'll add the numerators. Let's see, that's 12 minus 3 minus 10. That's -1. Denominator doesn't change, -1/4. And expected value, we're going to write as a fraction. So we'll go ahead and do that, or excuse me, as a decimal. We'll go ahead and do that division. -1 divided by 4 is -0.25. And That's the expected value of this spinner. What that means is a player who plays this game can expect to lose 25 cents per play over the long run. They can't lose 25 cents in one spin, but over the long run, they're going to lose 25 cents per spin. As is with any of these, let me know if you have questions. What I'm hoping is it's like, oh yeah, okay. It's a little rusty, but I remember this, and that you feel confident about it. Find the missing leg of a right triangle with one leg 12 feet long and a hypotenuse of 22 feet. So here we've got to remember some terminology. We've got a right triangle, and we're told that one leg is 12 feet long, and the hypotenuse, that's the longest side, the one across from the right angle, is 22. Okay, it's a right triangle. I need to find this missing side length over here, but I know two of the three sides, so I'm going to use Pythagorean theorem, which is leg squared plus leg squared is hypotenuse squared. So x squared plus 12 squared is 22 squared. And once we've solved that equation, we know how long that other leg is. Let's see, we can simplify here. X squared plus 144 is whatever 22 squared is, 484. Now, just a reminder of solving equations. We're trying to get x by itself, so we're trying to get that term by itself. So as we look at the left-hand side of this equation, we want to peel it from the outside in. The first thing we want to get rid of is that 144. So we're going to subtract 144 from both sides. So x squared is 340. And then in order to make squared go away, we're going to need to take the square root. So I'm going to square root the left and square root the right. Square root and squaring cancel each other out. And whatever the square root of 340 is, 18.4390. That keeps going. I was told in this one to round to the nearest hundredth. So we'll find the hundredths place, 2 past the decimal, look one space to the right, that's 5 or bigger. So we'll round this up to 18.44. They would be feet, but just 18.44. And on the final quiz, they're multiple choice. All right, a couple more to go. Similar figures, something pretty recent. Find BC and round your answer to the nearest tenth. So we have these elongated pentagons here, and we want to find BC. First, we establish a relationship between the two using corresponding sides. This 4 corresponds to this 3. So I can set up that ratio of 4 to 3 from the figure on the left compared to the figure on the right. And then since what I'm asked to find is BC, that's this side down here, then I need to use the corresponding side in the other figure to set up that ratio. And if I went 4 to 3, which is left then right, then I need to set it up as 9 over, I'll call it x, for BC. And so I've got my relationship established here. 4 is to 3 as 9 is to x. Now I can solve this proportion by cross multiplying. 9 times 3 is 27. 4 times x is 4x. And then in order to get that x by itself, we'll divide both sides by 4. Here they cancel, leaving just the x. And 27 divided by 4 is 6.75. I was told to round to the nearest tenth. So I'll find the tenths place, look one space to the right. Since that's 5 or bigger, we'll round this up and call it 6.8. Dimensional analysis. Use the fact that 1 inch is 2.54 centimeters and that 100 centimeters is a meter to convert 55 inches to meters. Okay, these conversion problems, it's hard to know where to start, but convert 55 inches to meters. The thing I'm going to convert, that's where I start. And I want to turn this into meters. So let's see here. As I do this, let's see, I need to get inches to go away. I'm going to look for a unit fraction that has inches in it. That's this one right here. 1 inch is 2.54 centimeters. I'm going to put my 1 inch on the bottom my 2.54 centimeters on the top because I want inches to cancel. So that's how I knew to put inches on the bottom, because I needed them to cancel. Then I have another unit fraction here that I'm probably going to need, but let's see here. I'm trying to get to meters, and right now I have centimeters, so I'm not there yet. I need to turn those centimeters into meters, and I have this fact right here. 100 centimeters is a meter, so my 100 centimeters goes on the bottom, my 1 meter goes on the top, and that's because I want to cancel centimeters. I started out with inches, now I have meters. That's what I was trying to get to. So I don't need to do any more unit fractions. I'll multiply across the top. 55 times 2.54 times 1 is 139.7. And meters are still there, so I'll keep those meters. And then I'm also going to multiply across the bottom. 1 times 100, well, that's just going to be 100. Finally, I'll go ahead and divide that. 139.7 divided by 100 is 1.397 meters. I was told to round to the nearest thousandth, so that's where I'm at. 1.397 would be our answer there. All right, we did